Lesson 9.5, Congruent Figures. Lesson 9.5, Congruent Figures. Congruent figures. Recall that segments and their images have the same length and angles, and their images have the same measure under a translation, reflection, or rotation. Two figures are said to be congruent if one can be obtained from the other by a sequence of translations, reflections, and rotations. Congruent figures have the same size and shape. When you are told that two figures are congruent, there must be a sequence of translations, reflections, and/or rotations that transforms one into the other. Key objectives: learn to identify transformations as similarity or congruent transformations.
All right, let's take a look at another pair of triangles and see if there's a transformation that takes me from one triangle to the other. So here I've got a red triangle, ABC, and a green triangle, A prime, B prime, C prime. Now just look at them. Certainly they look about, the same size, don't they? In fact, if you just visualize them and look at them, it seems like it's almost as if the red triangle was kind of just folded over onto the green triangle. Let's see if that really is the case. I've got a little portable red triangle here. See, that's a red triangle right there. And now I'm just going to literally flip it over the y-axis. So I'm going to technically reflect it over the y-axis, but let's flip it over like a page. I'm going to turn the page. Boom. And look at that. It fits on there perfectly. So just visually, it looks like these two triangles should be congruent. And it looks like the transformation is literally just a reflection across the y-axis. Now, we can confirm that for ourselves, actually, mathematically and with more precision, by just writing down, again, the corresponding vertices of what we think of as the image. So A prime, what's the corresponding, this, by the way, is the vertex for A, which notice is at negative 4, 0, that's that point. B is at negative 4, 3, and C is at negative 2, 0. So now let's look at the corresponding ones. A is at 4, 0, A prime rather. B prime is located at 4, 3, and C prime is located here at 2, 0. And notice, indeed, what do you see? What you see is that the y values, the corresponding y values are equal. I mean, are all the same. The corresponding values are the same. And the corresponding x values are off by a negative sign. So this is negative, this is positive, this is negative, this is positive, this is negative, this is positive. And that is the defining trait for the transformation that is a reflection over the y-axis. Because when you reflect over the y-axis, the y values, or the heights, don't change. The only thing that changes is, if you were negative before, you're now going to be positive. If you were positive before, you're now going to be negative. So in fact, the triangles are congruent, and the reason is because we can get from the red triangle to the green triangle by a transformation that is nothing more than a reflection across the y-axis. Beautiful, beautiful. Let's do one more, shall we? One more. This one, kind of cool. I'm liking. I got a red ABC. I've got a green A prime, B prime, C prime. And what do you think? Well, visually, it looks to me like they are congruent. Now, that doesn't prove anything, of course, but it's nice to make a guess, to start off with a little guess. Let's just see if we can verify that just informally. So here is the red original triangle. How would I get it to there? It looks like I would just slide it. Doesn't it kind of look like it's like a little dance step? It's like a slide. It's like the triangle walk. In fact, 1, 2, 3, 4, 5, 6. It looks like I slide over 6 places over to the right. And notice they match up perfectly. So it looks like we're going to actually have a translation. We're going to have a translation in the x direction 6 units over. That doesn't really prove anything, although it's pretty compelling evidence, I got to admit. It looks like we just go from here to here. So let's see if we can verify that by really quickly just looking at the original vertices of the original red triangle. A is negative 4, 0, B is negative 4, 3, and C is negative 2, 0. So that's what we had before. And now the new green, A prime, has coordinates 2, 0, and the B prime has coordinates 2, 3, and the C prime has coordinates 4, 0. And what do you notice? What I notice is that the y coordinates are all identical, and the x coordinate here is just literally exactly 6 more than this, right? Negative 4 plus 6 is 2. Negative 4 plus 6 is 2. Negative 2 plus 6 is 4. So this literally is equal to, the x's are equal to 6 plus the original x's. And I could write that down, actually, in a kind of nice way if I want to write a little version of it down. I'd say that, in general, the point x, y from the red triangle is transformed into what? Well, the x is just increased by 6, so x plus 6, and the y's remain the same. So that's actually kind of the fancy way of writing this transformation. And you can see what it is. It literally is a translation 6 units to the right, which is exactly what we saw, that kind of triangle walk, 6 units over. And then the two triangles coincide, which means these triangles are congruent. And the reason is because I can get from the red to the green with a translation transformation. And the translation is actually given by this. It's kind of a fancy way of saying, just take the x values and add 6 to them and do nothing with the y's. Very, very cool. So, by just seeing if you can find a transformation that takes one geometric object to another, you can actually study whether, in fact, the two objects at hand are congruent, and if they're not congruent, you can ask if they're similar. Really, really cool. Enjoy the geometric world all around you, whether it's in the coordinate plane or beyond. I'll see you soon.
Okay, a couple of things to recall from this particular example. One, make sure you know how to write the translation using the algebraic notation. Like you went, xy was the original, and after you translated it, the x values all had 6 added to it, and y stayed the same. That's the algebraic representation. Also, transformations that result in an image that is the same shape as the original but a different size are similarity transformations. Transformations that result in an image that is the same shape and size as the original are congruent transformations.